Now let's turn away from our present-day snapshot of energy use to look at how energy use has evolved over time. Let's start with the longest view, the last 1,000 years, a millennia of energy history. Over that time, up until about 1850, energy use changed very slowly. It grew by perhaps a factor of 3 in the millennia before 1850. And looking at this graph, which shows you the world per capita energy use in kilowatts, you can see the reason that energy use grew before 1850. And that reason was primarily just the growth in population, because per capita energy use was almost constant. After 1850, things changed dramatically. In the 150 years since then, per capita energy use has gone up by roughly a factor of 4, and population has gone up by more than a factor of 5, driving total primary energy use up by a factor of more than 20. So what's cause and what's effect? Access to fossil fuels increased energy consumption. That allowed many more people to be supported on the same amount of land. Think about steam trains replacing horses to transport goods to cities. The land that was used for supporting the horses could now be used for growing food. Or did some combination of social change and population growth drive the pace of technological and social innovation overall, with a dramatic increase in energy use being just one of many results? Maybe it's a bit of both, but I lean towards the idea that access to fossil fuels played a central role in the transformation the world has witnessed over the last few centuries, and in the enormous increase in population growth. There's simply no way the world could have supported that many people without a fundamental change in the way we powered it. Now let's zoom in on the last 150 years, about 2 human lifetimes. The first thing to notice is that essentially all energy supplies increase. Coal, then oil, then gas, then nuclear power. We've transitioned away from biomass as a major driver of the global energy system. See this graph that shows the fractional shares of primary energy supply. But humanity uses more biomass energy today than it ever did. So the central lesson is we keep using more of everything. This is the average, but let's look at the United Kingdom, where the Industrial Revolution started. It became roughly 50% fossil fueled in 1800, or perhaps just before. You may have heard of James Watt's steam engine, invented in about 1760. It was about 3 times more efficient than earlier engines. You may not know that one of the most important early markets for that engine was taking water out of coal mines. Coal mines deep underground flooded with groundwater, and so you couldn't keep mining the coal. The new engine allowed us to get that water out better, and that allowed us to mine more coal. I can't think of a better example of a chain reaction at the heart of the Industrial Revolution. That, in combination with many other such positive feedbacks, generated the extraordinary changes the United Kingdom has witnessed since 1800. In the 200 years since 1800, the UK has seen a tenfold improvement in the efficiency with which fossil energy is transformed into useful work. The increased energy supply has driven demand, which has tripled per capita energy use. This allowed a population explosion, with the population going roughly 5-fold from 1800 to its current value of about 60 million in the UK. Stepping back, it would be simply impossible to sustain 60 million people living on an island the size of the United Kingdom without a modern energy system to feed and clothe them. Now, let's zoom in one more time, looking at the last half-century and focusing on the differences in energy use between the world's regions. A few things to notice about this graph. First, this is the total primary energy that an economy uses. It's production plus imports minus exports. Notice that the US and Europe are close to flat. Their consumption has hardly varied in the last half-century. The last few years, in fact, have shown slight declines in the EU and the USA. China now uses more energy than the EU or the US, and its energy use has doubled in the last 12 years. Africa, the Middle East, and India all use a similar amount of primary energy, and they're all growing very slowly. Now let's take out population growth and look at energy use per capita over the same period. On a per capita basis, the decline in US energy use looks stronger, and you can see how extraordinarily constant EU energy use has been on a per capita basis. The world's energy use is up very slowly on a per capita basis. The Middle East has trended up steadily. China's transition is sudden. Starting this century, its per capita energy use went up at an extraordinary pace. Africa and India both have per capita energy use which is small and changing very slowly, but India is growing a bit faster and has just passed Africa. What explains the factor of 2 difference between European Union and American energy consumption? There are no easy answers. It's tempting to assume it's simply that America is more inefficient. But in fact, when you look on a case-by-case basis at the efficiencies of large industries or energy transformations, they're about the same. In summary, the reason that per capita energy consumption is so much higher in America than it is in Europe is mostly because Americans consume more energy-intensive goods and services, like long-distance travel and large houses. That, more than differences in energy efficiency, explain the enormous factor of 2 difference in per capita energy consumption. Now look again at the difference between the rich countries, EU and America, and Africa. The differences are even bigger than they look, because this graph is in primary energy per capita. But the energy systems are much more efficient in the developed countries. So the access to energy services is in fact much more unequal even than you see in this graph.